Okay, I'm getting this chat. Okay, so there are 10 people around here. All right. So very quickly, okay, let me start with my brief introduction. My qualification would be I've done my MBA Finance. All right, and I have more than 10 years of experience, wherein 5 years I have worked with the banking industry. All right, then I have moved on as a freelancer trainer, and I've started as a training for SAT sessions, which is for the people who go after their 12th standard in US for further studies, and then moved on to GRE GMAT, and then taking CAT sessions. All right, so I've been taking sessions for a couple of institutes. One is Test Rocker for SAT, and then Cafe Mentor, which is an online platform, and I am with Career Launcher too. So they are all on a part-time basis. All right. So this is very briefly on from my side. Okay. Now, before we just start the session, let me have a look at the numbers. What I see is there are 12 attendees here. If you can briefly tell me who all are, how many people are here engineers. So I hope just if you could, how many are engineers here? Or engineers are who have mathematic background as their in their graduation, mathematics or statistics. Okay, Shovik, yes, right.
वो कुछ शुरू हो रहा है, नहीं कर सकते। तो खाना बताओ ना क्या बनाना है। Hello. Hi, this is Shilpa from Spanedea. Alright, how many of you are from science background? You can reply to me over chat. Yeah. Right. That's great. We have got a number of students from science background also. So, are you people have done? Have you people done CAT preparation earlier also, or how many of you are freshers preparing for the first time? So that I'll be getting an idea on how to go with the progress of this session. All right. You've got a good number of people as a freshers also. Alright, just give me a minute. I'll ask tutor to resume the session, right? Hello, Akshaya? Right, so the tutor is ready to start the session again. Yeah, Ashwini, you can resume the session.
Okay. Hello. Yeah. So I'm sorry for this. There was some delay on this. All right. So I was just asking how many people were there. So around 3 or 4 people have replied as engineers. All right. So I'm assuming rest are from the other background. All right. Now, before we start on this, right, let's go very briefly on for the 2016. All right. So the CAT 2016, the pattern. All right. And since I'll be dealing with the QA, that is quantitative aptitude, we'll look at the quantitative aptitude, how the questions and what are the topics and how to prepare for it. All right. So let's look very briefly on the pattern. Now, if you see in this year's 2016, they have the total time duration now they have given as 180 minutes, and they have divided into 3 sections. So basically QA, your quantitative aptitude, then verbal and comprehension, and DI and logical reasoning. So giving them as 34, 34 and 32 marks. Now, since we are focusing on here quantitative aptitude, so let's look at the QA section. All right. Now, right. So
खाना बताते हैं क्या बताना है। कुछ नहीं आता, पनीर वगैरह, पनीर, शाही पनीर, शाही पनीर।
now, yeah. So now we'll just broadly focus on quantitative and what are the topics we have, and then into the topic of reminder theorem and looking at the number theory. All right. So if you look at the quantitative part of the the quantitative part of the CAT, they basically, if you see, there are three major topics. So one is your algebra, number theory, so which is the major content in CAT, which is around 50 to 60%. All right, Pallavi. Okay, Pallavi, is it clear now? Yeah. Okay. All right, Pallavi. So if you look at this thing, so broadly there are three parts into it. One is algebra, number theory. All right. Okay. All right, Tanish. Okay. Great. Great. Good. All right. So the second is geometry and mensuration. Now, when I say geometry, it includes coordinate geometry. All right. So geometry includes your circle, various this thing, and coordinate geometry plus the mensuration, which is comprises of 20 to 30% of your questions. And all right, and then comes the arithmetic or the miscellaneous topics. Now, these miscellaneous topics, when I say it, it basically deals with set theory and all. Now, very briefly, again, going to the content of these three topics. All right, the three major this thing. Now, when I say geometry, coordinate geometry, as I've already described, basically they are deal with your basic theorems on triangles, the property, similarity, and congruency property, circles, parallel lines. All right. Then you have coordinate geometry and that. All right. And then when I talk about algebra and number theory, the basic topics. All right. So here we'll be dealing with one topic here is remainder theorem. All right. The other topics in this would be related to permutation, combination, probability, fraction, progression, related to logarithm equations, basically on quadratic and linear equations. All right. So very briefly on we've gone through it. So if you want some detail on that, we can have that question answer session at the end. All right. So should we then move to the our topic which would be taking care? All right. Yeah. So number theory. All right. Yeah. So we'll just move on to number theory. Let's not waste time. Let me take out paint also so that I'll take up some questions, right? So that it would be convenient for us to write. Okay. This is not all right. Now, number theory basically will have around 4 to 10 questions. All right. Again, the common topics which I said: remainder theorem, HCF, LCM, divisibility tests related to prime number, factorial, questions related to it. Now, here we'll be first taking up a common topic, the remainder theorem. Now, if you have gone through and if you could just briefly tell me how many of you have given a CAT before, that is 2000 prior to it. Okay, there's one who has replied. Okay, Jatin Bansal. Okay, Neha. So 5 people I got. Okay, okay, Devnath. So around what I see is around again 6 to 7 people. Yeah, around to 6 to 7 people. So majority of the attendees here are would be writing the first attempt. All right. Okay, okay. So now if okay, okay, all right. So in that case, let me then go down and look at the strategy because there are many people who have not written CAT as of now. So all are fresher. Most of them are fresher. Looking at the numbers, 80, some 70 to 80% are fresher here. Now, so let's see. November end. So if you, Devnath, is it clear? Is it clear now? Is it clear now, Devnath? Yeah. Okay. Okay. All right. Yeah. Right. So if you look at that, it would be somewhere in mid-November. All right. Okay. Now, so if you are writing the CAT in mid-November, all right, Arya. So now, before that, prior to 1 month, so basically from October 15 to November 15, all right. So it would be, you would be writing the mock CATs, right? So I'm going from top to bottom, from backwards, all right. So that 1 month you have to go for mock CATs, all right. Mock CATs, as in, now minimum you have to write around, let's say 10, somewhere around 5 to 15 mock CATs. All right. Now before mock CATs, your preparation on all the topics. So as we have discussed, the three sections you have, right? So here we'll be only dealing with the QA section. All right. Now, so now when you deal with QA and looking at the audience here, so again the majority are from non-mathematics background. So I'm assuming they have to work on their basics first, right? Even I have looked at some of the who are very good at or are from mathematics background. They struggle with the basic concept of it. So now, as in we are 3 or 4 months away from this, so we have to start with the basic concept. So CAD is not all about just solving all the questions. Okay, so if you are aware of it, 30 around, if you attempt 30% of the question, right? If you attempt 30% of the question, you would land up somewhere around 90, 96 percentile or above. All right. So it is not all about attempting all the questions. So do not, do that mistake that I have to attempt all. It is not about attempting all. It is all about having accuracy. So you attempt 10 questions, let's say, assuming, all right, but it has to be accurate, all right. And for your information, whether you guys are know or not, so around no 3 to 4 lakh people, right? So you know how much is 50 percentile? The score in general, the score of 50 percentile are achieved for people who score 0 or less. So that means if you score 0, this again it's an arguable number. So it is not fixed that if you score 0 you'll always end up having 50 percentile. So from the previous data, if you see, if you would have scored 0, let's say last year paper, CAT 2015, if you have gone and just simply given your attendance and you have not marked anything, so your score would have been 0 and your relative percentile would have been 50 percentile. All right. So now this tells more critical that it is not all about answering all the questions. It's about answering the correct question. So someone who has scored just two questions also would have landed up somewhere around 60 percentile. All right. So it is not about this thing. Yes, Devnath. Yeah, in 2015. Yeah, that was correct. Okay. All right. Now, so that is how. So the basic should be the building up concept. So concept, now since we have 4 months time, so initially we'll start up with the all the concept building. So we'll take up one topic. All right, we'll take up one topic which I have chosen as on the number theory as reminder theorem. Let me, yeah. Now, reminder theorem. Yes, yes, yes. Shreya, there would be a sectional cutoff. So as I told you, it would be around 30%. So we'll take a rough figure and move ahead. So it will be around 30%. So that means, all right. So when I say 30%, So that is around, you should be able to, you are looking at a score of 95 plus, right? 95%, right? Generally, they say if you attempt 30% correct your this thing, it will end up having somewhere around 98 percentile or more. All right. So if you are talking about 50 questions, so basically that is around 15 plus. So we are looking at 15 plus questions to be attempted, correct questions attempted, to get somewhere around 98 percentile. All right. Okay. So let's move to the topic here. Yes, let's take up one topic and see how things work. So how many of you are aware of reminder theorem? If you could, somebody here is aware of reminder theorem, what is it and what are the type of questions? Okay, Neha, good. All right. Okay, Jatin, Urvashi, all right. Okay, so you guys are I hope you guys are comfortable with uh, this topic. All right. Then let's just briefly go on the topic, and then I'll give you a couple of questions, and let's see how many of them are able to answer it, and then we'll move forward with the presentation. Now, the reminder theorem, as it is there in this thing, if there are two numbers, natural numbers A and B, all right, where B is not equal, all right, where B is not equal to 0. Now, it can be provided there exists a unique integer Q can be returned. All right, there has to be one more condition here: A is greater than B. All right, so we'll say A is greater than B. All right, then A can be written in terms of B as Q into B plus R. All right, so your division lemma is also states the same thing, right? The Q becomes a quotient and R becomes a reminder. All right, and where R will take the value between 0 and right divisor here. All right, here in this case it is B what I've taken, so it will be between 0 and B but not equal to B. All right, that is what the reminder theorem states. All right, so your dividend is nothing but divisor into quotient plus reminder, so that's a base of it. So as I've seen people who have done this, so let's take one question. So if I tell you find the remainder of 23 into 24 into 25 divided by 7, so what would be the remainder? If you guys can prompt the answer, you can reply it on the chat. Yeah, okay. So most of you people have given an answer, 3, 2, all right. Okay, any more answer? So most of you guys have given 3, couple of them have given 2. Okay, all right. Any more answers? 4, all right. Okay, 3, 4. So I have answers as 3 and 4. Okay, so let's look at how we proceed with it. So basically, if I have a number, let me take down this. Yeah, Vikas, hello. Vikas, you can mute this thing, I think. Yeah, okay, okay. So now, how do we proceed with this? So I think most of you guys have done this, but for other people, let me briefly tell about it. Okay, so I've given 23 into 24 into 25 divided by 7, right? Okay, so let's take one number. So let's say 23 divided by 7. So what is the remainder? So that is 7 3 times is 24, right? So 2 would be the reminder, right? Yes. So if I do with the 24, the remainder would be 3. If I do with 25, so I'm basically dividing them separately with 7 and looking what are the reminders. All right, Arvind, you said 2. Okay, let's look at it. Okay, so when you divide by 25, the remainder would be 4. All right. Now, the the conventional way is you will multiply all these three numbers, all right, and then divide by 7, which would be a tedious process. So but the easier way would be used to divide them separately and look at the operations what they are happening. So you are multiplying 23, 24 and 25. So basically what I'll do is I'll multiply the reminders individually, all right. So 2 into 3 into 4, all right. So that is 2 into 3 is 6, 6 into 4 is 24, all right. So 24 on 7, so the remainder is 3, so the answer would be 3, all right. So this is a very simple question where we have applied the remainder and we got the answer as 3. So the correct answer is 3. And I think the other attendees who have not answered it, I hope this is clear for you. If you guys can yes. Yes, I think these are the guys, Chaudhary and Dev not, and you have answered it. So the guys who have not answered it, have you got this one? Yeah? Yes, Balu. Okay, you got this one. All right? Okay. Now, but there's one caution. There is one small caution you have to be careful about it. Okay? What is that? If you see on the slide, if you find the remainder after cancelling the common terms, make sure it is multiplied to the remainder. Now what does that mean? It means, yes, all right, Arvind. Okay, okay. So the note here, all right, the all right, the things to be taken care in this is this one. Let's say if I give you 9, once again, right? If let's say, yeah, if let's say I give you 15 divided by, let's say 9, all right. So people generally what they do is they simplify this. If you simplify this will become 5 on 3, yes, and then they find the remainder for this. 5 on 3, the remainder is 2, all right. Okay. Now, if you see, if you divide 15 on 9, the remainder would be how much?
Hello.
9 ones are 9. Hello. Yeah, Vikas. Vikas, is it? I think, yeah. So the remainder would be, yes, 6. So this is the only catch you have to be, or you have to be careful about it. Yes. So if you see the 15, the remainder is 6, but not 2. So whenever you are reducing it to the lowest term, okay, so lowest term, now that will not be the remainder. So what you have to do, if you have converted that to the lowest term, then whatever the remainder you get, you multiply to the common factor. So here the common factor was 3, right? So you cancelled with 3, so 3 was the common factor. So you multiply by 3 to get the answer. All right, is it clear? This is the only note or only caution you have to take care. If you are converting the fraction whatever they have given to the lowest term. All right. Yes, guys, hope this is clear. The caution part which I have mentioned here. Oh, okay, okay. All right, all right. So then we'll move on to some different Okay, after multiplying we get 5. No. Shreya, you multiply the remainder 2 to the common factor, which is 6. No. Neha, we have to multiply by divisor. No, not divisor. If you have cancelled it, that is made into a lowest term, multiply. Okay, take. Okay, Devnath will take one more example. Let's take 24 on, let's say, uh, yeah, sure. Okay, you understood it, right? Okay. But for, okay, let's take some other example. Let's say 24 on 10. All right. So when you divide 24 and 10, what is the remainder? Actual remainder is 4, right? But in case you simplify this, yes, but let's say you have simplified it. So which is 12 on 5, right? You have made this into lowest term. Now the remainder is 2. Okay. So when you make them into the lowest term, then you multiply the remainder 2 into the common factor. So what was the common factor between 24 and 2 here? It was 2, right? So the actual remainder would be 2 into 2. 2 into 2, which is 4. Is it clear? Yeah, Devnath? I think you have asked for it. Okay, all right. So this is one, this thing you have to take care of it. All right. Let's take some more examples, different type of example and see how this work. There is one question which has come up, I think, in previous, not a couple of this thing, it's around 2005 or 6 CAT question. So let's take that question and then work on it. Now, let's say find the remainder when 1 factorial plus 2 factorial plus 3 factorial, right, up to 100 factorial. Yeah, 1 factorial. Oh, 1 second. I think somebody is there here. Guys, if you can mute everyone. Yeah, okay, all right. Now, so the question is, find the remainder when this 1 factorial, 2 factorial till 100 factorial is divided by the product of 7 natural numbers. Divided by product of 7 numbers, natural numbers. Yeah. Hope you get my question. So what is the remainder when 1 factorial plus 2 factorial plus 3 factorial up to 100 factorial is divided by the product of 7 natural numbers? Arvind, you have to divide by the product of 7 natural numbers. That is 7 first, sorry, not any natural number, first 7 natural, my mistake. Yeah, this is first. Product of first 7 natural numbers. Yeah. Uh, any answers? So the question is basically 1 factorial, 2 factorial couldn't do. All right. So okay. Anybody is attempting it? Okay, Urvashi. So do you have any answers? Okay, okay, all right. So just take another 30 to 1 minute and then see if I get some answers. 873. So the reminder you're saying as 873. Okay. Sum of first 6 factorial. No, 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 no. I said divided by the first 7 natural numbers. So that would be natural number starts from 1, right? So that would be 7 factorial. Okay, 873. One more answer I've got as 873. Okay. Okay. Let's see how we'll proceed with the sum here. So basically they are saying you add 1 factorial, 2 factorial, 3 factorial up to 100 factorial and then divide by the product of 7 natural numbers. So product of P of 7 natural numbers, 7n is nothing but 7 factorial and not 6 factorial. Somebody has taken 6 factorial, so you should be careful. Natural numbers starts from 1. So you have to divide by 7 factorial, right? So basically what we have learned, so basically when you are dividing by 7 factorial, you will keep dividing by 7 factorial to the individual number. Alright, so when we divide it, so basically Urvashi, okay, 5. Oh, I'm sorry. So somebody has 5. Okay, okay, okay. Let's look at this, how to approach it. So basically what I'll do, I'll divide every number, that is every factorial, by 7 factorial to get the remainder, to look at the remainder. Yes. Okay. Now this I'll do, but see here, 7 factorial on 7 factorial plus 8 factorial on 7 factorial up to 100. Now from 7 factorial onwards, yes, from 7 factorial onwards it would be a perfect, because 7 factorial would become the factor of all the other factorials. So here the remainder would be 0, right? From 7 factorial onwards all the remainder would become 0. So this is done. So we are looking till 6 factorial by 7 factorial. So now what would be the remainder here? In the first case the remainder would be 1 factorial, right? I'll type in here. Yes. So the remainder here would be 1 factorial plus here the 2 factorial. So whatever, because they are small numbers, so whatever the number is, that would become the factorial. So we'll add up all the factorials. 3 factorial, 4 factorial, 5 factorial and 6 factorial. Yes? Yes, sure. Just add them all, right? So this is another type of sum. Now, there is another type of sum where we'll take one more type of sum and then move on to the next concept. Shreya, how we can omit? Omit, I didn't get. Shreya, this is related to the question I have asked. Okay, okay, let's proceed with it. Let's take one more sum. Oh, how we can leave this thing? Yeah, yeah. Okay, 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 okay. Let me write down again. So basically, we have done this 1 factorial by 7 factorial. You know. Okay, let's just focus on 7 factorial by 7 factorial. All right. So what do you mean by 7 factorial by 7 factorial? So basically, the remainder is 0 here, right? Yes, the remainder is 0 here. Now, okay, 8 factorial by 7 factorial. 8 factorial by 7 factorial is nothing but 7 factorial into 8 by 7 factorial. So that is what I said. From 7 factorial onwards, it will be a factor. The 7 factorial is factor of all the factorial till whatever they have given, 100. So that is the reason they become 0. So the remainder becomes 0 for rest of the terms. So we'll just keep adding from 1 to 6 factorial. Is it clear, Neha? Neha, we are looking at the fact reminder. So we are not looking at the question. All right. If you so here you should be very careful that I've asked you to calculate the reminder and not the question. Yes. Reminder would be no. Okay. I think you guys have this thing. Okay. When I say 8 factorial by 7 factorial, right? So see, let's take this example. Let's take this one. To simplify this thing, 2 into 3 by 2. So you're telling me 2 into 3 by 2, the remainder is 2. What is the remainder when I multiply 2 into 3 by 2? No. Yes. Neha, to clarify yourself, okay. Not all of them have a problem, but just a couple of them have asked the question, so I'm taking up this. So when I say we are looking at the remainder, okay, so be very careful when we are looking at the remainder. I'm not asking you the question. So 3 would be the question, all right, but the remainder would be 0, all right. So similarly, 8 factorial by 7 factorial would be 7 factorial into 8 by 7 factorial, all right. So basically it is a multiple. So 8 factorial is a multiple of 7 factorial. So the remainder would be 0. So there would be no remainder. All right. If it is a perfect fact, that is, if it is a factor, the remainder would be 0. That is the reason we will leave out all the reminders from 7 factorial because they are 0. Yes. All right. Okay. So let's move on to the one more type of sums, and then we'll take to the next topic, which is a negative remainder, which would be more helpful in solving sums. Okay. So let's take one more sum before we move on. Let's take one more type. Yes. So which is 64. Let's say take this one, 64 to the power of 999. Let's say divide it by 9. What would be the answer here? Uh, and careful, I'm just asking the reminder. You have to be very careful. I'm asking reminder when 64 to the power of 999 is divided by 9. Okay, you guys can give me the answer here. There is one more query. Let me take up this. Okay, Rudranshu. Okay, Rudranshu. Uh, yeah, Rudranshu. When I have a numerator which is smaller than a denominator, let's take an example 3 on 5. All right. So when I divide 3 on 5, what is the remainder? It will be 3, right? Yes. Okay. So when your numerator is smaller than your denominator, the remainder would be the numerator itself. Okay. So that is the reason 1 factorial by 7 factorial, the remainder would be 1 factorial. For 2 factorial by 7 factorial, the remainder would be 2 factorial, and so on. So hence we'll keep on adding 1 factorial, 2 factorial up to 6 factorial. Is it clear, Rudranshu? All right. For this question, most of you have answered 1. Okay. So basically, what you have to do is it is nothing but 64 into 64 into 64 till whatever the times they have given, 999 times divided by, right, 9. So 64, so you just look at 64, 9, what is the remainder when you divide 64 on 9, right? Yes? Okay, is it clear, Rudranshu? Yes, okay, great. So you divide 64 on 9, what is the remainder? 1 is the remainder, right? Is it clear? So every time the remainder is 1. So 1 into 1 into 1 into 1. So all would be 1, 9 times, 9 times. So that would be 1 itself. So you'll have 1 by 9 is 1. Alright? Yes? I hope these are the basic things on the reminder which I've taken. So just look at the thing. I think most of you guys are comfortable with this. Alright? Any more doubts on these type of questions? Any doubts? Anybody has any doubts on these type of questions? No, they are very basic questions. I've taken up the very basics of it. I hope no. Okay. So now we'll move on to the concept of negative reminder, right? Now, before doing the negative reminder, let me give you one more example so that we'll understand why the concept of negative reminder is. Now, if I give you, let's take up a simple number, 2 to the power of 21 is divided by 3. What is the reminder? Yes, can you guys can tell me? Yes. Can you guys tell me what is the reminder? 2 to the power of 21 divided by 3. When you divide 2 to the power of 21 divided by 3, what is the reminder? Can take 1 minute and let's see, can I get some answers? Anybody with the solution? What could be the possible reminder? No answers? Anybody is trying, attempting it? Alright, so I got a reply as one of the answer as -1. Alright. Anybody else? Or should I proceed with it? Okay, the answer 2, I'm just writing down the answers, -1, 2, okay, 2, okay, I got this one, -1 or 2 is same. Okay, alright. Any more answers or should we move? So we got some of the answers, somebody stating -1, 2, -1 or 2, -1 is equal to 2. Okay, alright, we'll talk about it. Alright, let's talk about it. Now, before we, if you follow, will follow the, if you follow the routine pattern, so basically what we'll do is 21 times, yes, divided by 3. Always end up having what? 2 to the power of 21 on 3, right? So that, so what they have done is we have a cheat of it. So which is the concept of negative reminder, all right? And for those of you guys who have given us -1 and telling -1 is equal to 2 and all, now tell me, so that is not ask you a reminder. Reminder cannot be a negative one, all right? That should be very clear. That, okay, that should be very clear because it would be greater than 3 and there is no possible, there is nothing called negative reminder. So when we talk about negative reminder, this is a cheat one, all right? So we cheat on the concept and try to get the answer easily. Okay. let's talk about it. Okay. Yes, Mohit. So let's see what negative reminder says. All right. So basically, there is nothing theoretically. There is nothing wrong with it. All right. So when I talk about negative reminder, theoretically it is not correct. So let me give you an example. Yeah, yeah. I'll just explain it. So when I say negative reminder, what I so you should be very clear. Algebraically, I can write 2 as 3 into 1 plus of minus 1. Yes, this is algebraically correct because the equation says 3 into 1 minus 1, which is equal to 2. But theoretically it is wrong because you cannot divide 2 in 3 parts, right? As a whole number, right? So it would be in fractions, right? But algebraically this would be correct. So now this is what how negative reminder helps you understand, to get the answer easily. So what we do is we write this in the algebraic form using the reminder and write the negative reminder. So here the negative reminder is minus 1 in this case. So when you divide by 2 on 3, so basically we say negative reminder. But alright, okay. So let me take this once again. See, negative reminder as a theoretical concept does not exist. Alright, okay. But algebraically and equation wise, I can write that equation, right? So 2 can be written as 3 into 1 minus 1. Yes, but in theoretical, that is you divide 2 on 3, you will never get negative 1, right? So that is what we say. Theoretically it is not correct, but algebraic equation is correct. Now, how to get a reminder? Because reminder cannot be a negative. So what we do is we just add whenever you are getting a negative reminder, a reminder, we make it positive by adding the divisor. So add the divisor. Alright. So whatever your negative reminder minus 1 plus the divisor here is 3. So that would be 2. So the reminder when you divide 2 to the power of 21 by 3 would be reminder is 2. Okay. Yes, the negative reminder is minus 1, but that is not correct. Alright. So you cannot try justify that reminder is minus 1. No, that is not the reminder. Okay. The reminder is 2. Is it clear? I hope this is clear. Okay. Okay. Now, there are some concepts. Now, let's take this one. So this is what. So whenever you are getting a negative number, that is negative reminder, you have to make it positive by adding the divisor to the negative reminder. All right. Now, there are some important. Yeah. Uh, Jyoti, I'm sorry. This one when while finding reminder, can we use the concept of negative reminder? Yes. Yes, but see, negative reminder can be used most of the time when your numerator is smaller than the denominator. If I have to take some question, see, where, let's say, one second, give me a minute. I think this is not working. Give me a 1 minute. Give me 1 minute. I'll be just there. This paint has got stuck. Hello. Yeah, there was some problem with the paint here, so it's working now. Yeah. So yes. Okay. Now, if I have to take some more example of it, uh, now if you say 41 into 42, let's take one more this thing. When you divide by 43, right? So 41 into 42 divided by 43. So what could be the remainder here? Okay. So okay. All right. So basically, what again? See, the number is less than or this thing. All right. There is 2, 1 answer. Okay, let's look at it. So again, your dividend, that is the number which is getting divided is less than your divisor. So here again we'll use the concept of negative remainder. So basically it would be minus 1, right? When you divide 41, so negative remainder would be minus 2. So getting multiplied into minus 1. If you divide 42 on this, the negative remainder would be minus 1. So minus 2 into minus 1 is plus 2. Now, if you have plus 2, this is positive, we will not change it. Okay, you change, you add your divisor when your remainder is negative and not positive. So here we got the remainder as positive, so because negative of 2 into negative of 1 is plus 2. So once you get a positive remainder, so the remainder would become plus 2. Okay, so you have to be careful with this. So which I said, negative remainder, you have to change the negative remainder, that is add to the divisor only when it is negative, right, and not when it has become positive. Okay, if I have the same, now if I give you the same sum, 40 into 41 into 42 divided by 43, all right. Now in this case, the remainder would be negative 3, negative 2, negative 1, right? In this case, the remainder would have been negative 6. In this case, you will add it. So remainder would be 43 minus 6. Okay? Yes? Is it clear? Okay. Now, there are some more important concepts on this, all right, which you guys, which has to be remembered, all right. Now, to remember this, again, if you remember the concept, it would be easier to remember these formulas. Sure, that would be for this one, 43 minus 6, so which would be 37. Yeah, but in this case it would be only 2 because it has become to a positive remainder, so we will not add the divisor. Yes. Okay. All right. Now these are some important formulas. Okay, if you see the first one, if you look at this format, whenever you look at the sum which is in this format, now if you look at the first one, so the first format, if you see, is, I'll write it down, it is ax plus 1 to the power of n divided by a. All right. So when anything of format ax plus 1 to the power of on a, the remainder would always be 1. Okay. Let's take an example. Okay. So you don't have to do the remainder every time. If you see this pattern, let's take an example that is 100 to the power of, let's say, 99 divided by 11. Okay. 100 to the power of 99 divided by 11. Now, when you see a sum like this, you just can see that this 100 can be written as in terms of 11. that is ax plus 1. Yeah, so 100 can be written as 11 into 99 plus 1, sorry, 11 into 9 plus 1 to the power of 99 divided by 11, sorry, divided by 11. So see, this is in the format of ax plus 1 to the power of n on a. Alright, so whenever you can write this format, you can directly write the remainder. So whatever the remainder is left out, you just write 1. Yes, so this is the first format. So if you have a format like ax plus 1 to the power of n by a, alright, so basically here what we are checking is if your numerator, yeah, your numerator can be written as a multiple of denominator plus 1. So you can directly write as remainder as 1. Okay, so 1 is left out. So these are basic formulas. Okay, so basic formulas to remember. Okay, so once you, so ax minus 1 to the power of n by a, okay, would be 1, right? Now if you says for all the values of n, so okay, for all the values of n, but the second one for n is even, alright, ax minus 1 to the power of n upon a will be have remainder 1 when n is even, and when n is odd it would be a minus 1. Now to take up an example, let's take one example of the second one, ax minus 1. So we have seen ax plus 1, right? So ax plus 1 would be a straightforward one, okay, to the power of n by a. Okay, so this could be, let's say, let's take one example as 21 to the power of 875 by divided by, let's say, 7. Yeah, let's, yeah, 17. Okay, right? Now what could be the remainder here? 21 to the power of 875 on 17. 21 to the power of 875 divided by 17, what could be the remainder? 'Yeah, can anybody can work on this? 21 to the power of 875 by 17. 16. Okay. Any more answer? Okay. 13. All right. Any more answers? Okay. Let's see. Okay. I'll just work on it. So basically, it's nothing but 21. Okay. 21 875 times on 17, right? So what is 21? A remainder is 4, right? 21 divided by 7, the remainder is 4. So basically we're looking at, I'm sorry. One second. Yeah. Okay. All right. So we are looking at 4, right? So 4 to the power of 875, yes, on 17, yes. Now Again, now your numerator has gone below the denominator. So this you can apply the, now can you apply the negative theorem here? Negative reminder theorem here. Can we apply negative reminder theorem here and solve it? Yes. Okay. Okay. Let's put the 4. Yes. So basically, I can write 4 square, right? So 16. That is 17 minus 1, right? So basically, I have to write this in the form of 16, right? Can I do that, right? So this can be written as 4 to the power of, instead of doing this thing, a negative reminder, I can write this, because once I see 17 here, can I write in terms of 16 or one number ahead, that is 18, right? I need to look, can I make this into 16 or 18, right? So 4, I know 4 square is 16. So if I can write this into 4 square, then the problem would be solved. Or if I can write this in terms of 18, okay, if I can write terms of 18, even that would help me, because if I can write in terms of 18, then I can write as ax plus 1, okay, but I cannot write this in 18 because 4 of any power is not 18, so I'll write in terms of 16 because I know 4 square is 16. So this can be written as 4 square to the power of, yes, right, 2 to the power of 437, right? Yes, is it fine? Then plus, uh, yeah, is it fine, into 4. Are you guys getting it? Yeah, divided by 17, right? Now if you see this, I've converted this into 16. This will be, I can write this as 17 minus 1 to the power of 437 star 4 on 17. Now your power is odd here, so if power is odd, the remainder would be a minus 1, okay, where a is 17 here. So remainder would be 17 minus 1 is 16, right? Yes, is it clear? Guys, is it clear till here? Yes. Okay. So a minus 1 would be the remainder. So which would be 16 into 4 on 17. So 16 into 4 is 64 on 17. So 64 on 17 is, the remainder would be 13. So the answer would be 13 here. Alright. Yes. Now there are some more few this thing, short direct formula, but again they have been, you can take examples and check on them, all right, why they have derived on this. So there are few more, so it will take it will take another hour to explain all the other examples, but you can go through it. I've just jotted down some of the major pattern which which are being followed. So you have a to the power of n plus b to the power of n by a plus b. The remainder would be 0 when n is odd. So you can look at it. Okay. So I think we'll wind up the session till here. Okay, you can ask any query regarding this if you have any specific questions on this topic. Yeah, anybody has some specific? They they've not. I think you have to coordinate with Spanedea for this. Okay. Yes, they would help you. You know, because yes, you have to coordinate with the Spanedea for this. Any other specific query or related to the topic or the QA section in general? Yeah, thank you, Malini. Yes, because we have very limited time, I was not able to cover other things. Yes, HCF and LCM part of it, because we'll follow it with HCF and LCM, right? So that can be taken care. You can coordinate with Spanedea. I think they will be sending you across one email. Okay, yeah, and uh, yes, everybody, you can have a look. You can just you know this is some promotional event happening with Spanedea, so you guys can provide. I think Spanedea would be providing with you with some form of some pamphlet where you can provide your feedback, all right, and you can have 1 hour of personalized class for the same topic, or for some other specific topic you want. We can take 1 hour free 1 hour of session with me, all right. Yes. uh, Somebody has asked the book, about book, right? See, about the books to be covered, right? Now this has to be taken care by it will differ from student to student, all right. Now here in this session I have seen many non-mathematic students are there, right? So you have in the market there are 3 or 4 books which are majorly there. One was Arun, this thing of Tata McGraw-Hill. But those who are on a very basic level, those who want to understand the first the very basic, and I'll ask them to go through this thing, Abhijit Guha. I think they have in that book they have gone on a very basic level, basic questions, dealt with it, and they have given a formula, shortcut of it. So that has a very structured book. Once you are dealt with that, you can move to the other books. There are many other books also on it. So that should not be. It will depend from how where are you starting from. Abhijit Guha on. Abhijit Guha, I think this I don't know what it's quantitative aptitude for CAT itself, I think, or MBA entrance examination. Now this is for mind you, this is for the students or those aspirants who are want to start from a very basic level. All right. So let's start. No, start on that. See, numbers is yes. So, see, that is what I've told you in the very beginning. It is something. It is not that couple of sessions you do, or you read one book and you will be able to crack those questions. This thing. So this has to be done on a very structured pattern. So you have to learn the first the basic thing. All right. Once you learn the basic thing, basic concept of what is reminder, let's say what we have done, okay, okay, and then move on to the sum. So on a you have to initially you have to put in a lot of hours on the basic thing, then move on to some typical topics like uh, you have material from various institute also, even that would help you. So directly moving to those questions might not help you, at the first. So go step by step. I would suggest go with the very simple questions, understand them how they this thing. All right, great, great, good job. I think we'll wind up the session here. Any further query, you can mark a mail to you can no, write it to Spanedea, and they will forward it to me. All right. So we'll wind up the session here. Yes. So all right, it was great. Thank you for attending this session, and good luck for your preparations. Hope you would do well in this examination. All right, great, great.